Alhamdulillah, I'm good. Continue. It's our 10th lecture for Introduction to Computing Mathematics, and today we are going to start our fifth learning outcome. And this learning outcome is basically related to our new topic, which is about the probability. Probability, we call it something that is much related to a term in which we talk about the consequences of the occurrence of something. Like if you are talking about the rain, is it raining or not, or will it rain or not? So there are always two possibilities: either it's yes or no. Whenever you are confused in such kind of situations, we talk about the term probability. We use this term to drive the results that are basically related to our study. So in this today's class, we will first learn the probability theory and concepts, and also will explain the probability formulas that could be used for computing. So these terms are basically related to the probability concept. First, we need to understand it, because once you know what is probability, then you can deal with it. So probability is a branch of mathematics that is concerned with the analysis of random phenomena. The outcome of a random event cannot be determined before it occurs. So before the occurrence of something, you cannot say like 100%, you cannot say what is going to happen, but it may be any one of several possible outcomes. The actual outcome is considered to be determined by chance. Like you will see the chances of the occurrence of something, and then you will basically understand either it could happen like that or not. So if we talk about the simplest example of probability, it's the coin flipping. When you will flip a coin, there are only two possible outcomes, and the result is either heads or tails. We cannot have any other option or any other possibility from the results of the coin flipping. So when you have the fixed number of consequences, and from which you need to see which one is going to occur, what you can do is you can simply check their chances of occurrence. And how we can check that? Probability concepts gives us the formula that basically helps to determine the chances or the percentage of chances of the occurrence of something. So just let me know, is the concept of probability clear? Okay. So, probability is used to make predictions about how likely it is for an event to happen. As I was already talking about it, given the total number of possible outcomes, like the possible outcomes are basically it depends upon the condition. What is the condition? If the condition is having two consequences, you will say the total number of possible outcomes are two. But if it is about six or seven or somehow whatever the number is, the total possible number of outcomes could be the total number of possible outcomes from which you will see the event of happening of something. There are many events you cannot predict with total certainty, but you can predict the chances of an event happening. Either it's going to happen or not. If an event has the probability of zero, that tells you the event is impossible and wouldn't happen. For example, if you are talking about something which is totally uncertain, like the situation is totally not in the favor, like if we are talking about the flipping of coin, and we say that although we are going to flip it, and after the flipping we are going to check the probability. But if we say the coin will not flip, this is not an option. So the possibility of this thing is zero. So we can say this will never happen. Whenever you are going to flip it, it has to be flipped. We cannot say it will not flip or it may not flip. It will definitely flip, and we will get the probability. So if an event has a probability of 1, that tells you the event is certain and will happen. For example, if an event has a probability between 0 and 1, that tells you how likely the event is to happen. For example, it will rain or it will not rain. There are two conditions. So what we can say is the probability of raining is 1 and of not raining is also 1. We have two possible options. One is it will rain, the other one is it will not rain. So when you have two possibilities of something or an event, what you say is if the probability is 1, it has a certain chances to appear. But if it is between 0 and 1, like if you have the continuous changes in probability, it may rain. If it is cloudy, it may rain. If it is sunny, it may not rain. If such conditions also are present there, then you can say that the probability is less likely to happen, but it may happen. So if the probability is clear between 0 or like 1 and 2, there are more significant chances. And if it is between 0 and 1, like if it is continuous, then there are certain chances of its appearance or not appearance. The closer the probability is to 0, it's like the less likely it is to happen. And the closer the probability is to 1, it is like the more likely it is to happen. For example, if we talk about it will rain, if it is sunny, it will rain. If it is cloudy, it will rain. If it is cloudy, then it is more near to rain. So we will say that the it is cloudy is more close to 1. So we will say there are more chances of it to rain. If it is sunny, it is more closer to 0. So it has less chances to rain. So this is how we define the term probability and its occurrence points. I hope the concept is clear. If it is not clear or you have any question, you can ask me. So why the probability is important? You use or see probability all around you on a daily basis. Usually, when we take the general examples, we use this term in our daily basis life. We cannot say this is a mathematical term and we are not going to use it in our daily lives. No, it is completely used. How we use it often, although we don't use the mathematical terms to define it, but sometimes we talk in statements, like just like I was talking about rain. So when we talk about rain, generally we are talking about the concept of probability. Even if you don't realize it, you use probability every day to make the decisions about things with an unknown outcome. Because sometimes when you are going to decide something, or just like if you are going to decide which outfit you should wear, and you are going to check the weather according to it, so in your mind you already conclude things according to the weather, and you make a probability like if there it is sunny, it may not rain, so you can wear this cloth or this cloth. So this is something which happens in our mind, but ultimately we are using them without even realizing that we are using the concept of probability. So in general we are using it in weather conditions, like when we are looking at the weather and try to determine which is going to happen. In sports we use it like if some players are playing very well, so according to their play, how they are playing, basically we determine they this player may win the race or the other may not, and it is basically happening on the consequences that are already there. Insurance and games are also being used in this term. We are using the concept of probability, it may happen or not, and how we are going to win or not. And if we talk about the games are also when we talk about the Ludo and we talk about the dice, it has the six possibilities to occur. And when we play it, we have the six possible outcomes that can come, and we can determine the possibility of one like number one, two, three, four, five, and six, like how often they are likely to occur. So this is the whole scenario. In each and every scenario we can use the probability concept to gain the chances of their occurrence. We have different types of probability, and we can classify them into classical, empirical, subjective, and axiomatic probability. We can determine their chances by looking at the concept that is already mentioned. So, I'm going to start the classical probability. This is basically a theoretical perspective on probability that states in an experiment where there are x equally likely outcomes. X is basically the number for which we are saying there are x number of likely outcomes, and event y has exactly z of these outcomes. Then the probability of y is, because y is an event and we have the possibility of occurrence r z, so we will divide z by all the possible likely outcomes, which is x. So y is equal to z by x. So when we talk about the probability of y, we define this term like this: P of y is equal to z by x. Z is the likely events, or the probability of the the occurrence of the one number or one probability of all the possible outcomes that are basically mentioned in the experiment. So this is often the first perspective that students experience in formal education. For example, usually this is one of the most commonly used example, rolling a fair die. Whenever you are going to flip a dice or play with the dice, there are six possible outcomes that are equally likely. Anyone can occur anytime, so you don't know which one is going to occur. You can say there is one here. We will say that the z is 1 and x is 6. X is basically the total number of likely outcomes, and 6 is 1 is the actually outcome that is going to occur. So the probability of rolling each number is 1 by 6. If we will talk about the number 2, its probability is also 1 by 6. If we talk about the number 3, its probability is also 1 by 6. And each and every number is having the probability of same probability of occurrence. This is the basic formula in which we have like if we have number of outcomes, number of possible outcomes, every number have the equally likely opportunity to occur, and the chances are equal for each number. Is it clear? The classic option is clear. Classical probability is clear. Okay, so next we have the empirical probability and empirical or experimental perspective. The previous one was the theoretical perspective. Here we have the classical one was the theoretical perspective in which we generally talk about the theory concepts. Here we have the experimental perspectives on probability, and it defines the probability through thought. Basically, it is thought to have the experiments that are being done, and after that, we can say it is going to work like this. If you are rolling a weighted die, but you don't know which side has the weight, you can get an idea for the probability of each outcome by rolling the die on enormous number of time and calculating the proportion of time the dice gives that outcome. So here they have changed the condition. They say that if we are going to roll our dice, but we don't know which side of the dice is weighted, and definitely we know the weighted side has the more significant chances to occur. So what how we can see this experiment, we will do this experiment number of times, like multiple number of times, to get the maximum outcomes. Once you will roll that die around 50 times or 100 times, you will get the significant number of results, and you can see the number which is coming for more times, then you can say this is the site which is weighted in that dice. So this is an experimental perspective of probability in which we do some experiment, like we repeat the experiment number of times to get the valid results, and then we estimate the probability of that outcome with that. Next, we have the subjective probability. The subjective perspective on probability consider a person's own personal beliefs or judgment that an event will happen. For example, this is basically related to your own beliefs. Just like I was talking about weather, it's my own belief that if it is cloudy, it will rain. So this is what I am thinking of. This is what I have the idea for. Like it's totally my belief that if it is cloudy, it will rain. So, for example, an investor may have an educated sense of the market and intuitively talk about the probability of a certain stock going up tomorrow. So, this is something which is talking about the experience of someone. If someone is talking on his experience, just like if I am a teacher and I know which question has the more the possibility to occur in the exams, this is what I have gained the experience. So if I am saying like this question is important and you need to work hard on it, this is something which is directly related to my experience, and this is my personal belief. And although it may or may not happen, but still I have some beliefs and I will work on it. So, just like the stock person who is having good education and relevant experience, he is talking about the stocks that is going to hold on tomorrow. You can rationally understand how that subjective view agrees with medicine and experiment. Although This is basically something which they have gained the experience from some of the theoretical and experimental views. In the previous times, he may have done some of the experiments to see either the probability of what he is saying is more or not. If he is saying about this thing, so we can say that this is something which agrees to theoretical and experimental views, because these two are also interrelated with each other. In other words, it's the probability that what a person is expecting to happen through their knowledge and feelings will actually be the outcome with no formal calculations. Here we are not going to talk about any kind of formal calculations, just like in the theoretical one we had the experience, and in the then in the subjective ones, sorry, empirical ones, we have some of the performances of the probability so that we can see through our experiment how it is going to behave. In this one, we are generally talking about some feelings and some knowledge of the previous probability concepts that are being performed, so that we can understand which is going to happen. Just let me know if you have any question. So, for example, here we have another example for the subjective view. If a fan at a football game states that a particular team is going to win the game, they are basing their decision on the team's past wins and losses. Once you are following someone who is going, like, let's suppose who is a player, and you have seen all the matches that they have performed previously. So on the basis of your judgment, you can say in such conditions where the match goes like this one, usually these teams win or lose the game. So you can say that on the basis of your previous experience, what they know about the opposite team is something that is related to the facts they know about football and their opinions or feelings about the game. They are not making a formal mathematical calculation, but what they are saying, they are giving you their thoughts on the basis of the previous experience that they had with certain team. The next one and the last type of the probability is the axiomatic. This perspective on probability is unifying perspective where the coherent conditions such as used in basically theoretical and experimental probability proves the subjective probability. Here what we do is we think of we take the theoretical and experimental probability and define the subjective probability on it. Although the subjective probability is not about performing anything, it is about the beliefs and the previous knowledge, but in this type we classify that term into more detail and we apply theoretical and experimental probability on it. You apply a set of rules or axioms by Kalamorgov or to all types of probability. This is basically related to mathematicians who know them as the three axiom of them, and while using axiomatic probability, you can quantify the chances of an event occurring or not occurring. So how you can do that? You can simply check their axioms and you can define them. What are the three axioms of them? You can use the three axioms with all the other probability perspectives, like if you are talking about the theoretical, the experimental, or the subjective one, you can apply these axioms on all types of probabilities. But definitely this is another type of probability, but this is more classified and more detailing, because with the help of this probability you will apply the significant rules on each type of probability to get determine the results of it. The definition of this perspective is the probability of any function from numbers of events satisfied by the following three axioms. And the three axioms are: 0 is the smallest possible probability and 1 is the largest. We have only two probabilities, 0 and 1. 0 is the smallest, 1 is the largest. An event that is certain has a probability of 1. If the event is going to happen and it's going to happen, then what we are going to say, this has the probability 1. Two mutually exclusive events cannot occur simultaneously, but the union of events says only one of them can occur. Let's suppose we are talking about the rain. If they are interrelated, we cannot classify them separately. We will say that if they are generously going through, only one will occur. Just like I was talking about rain, If it is sunny, it will not rain, and if it is cloudy, it will rain. And we cannot say both have in this type. We cannot say both have the equal opportunity to occur. If it is going to rain, then we will say the sunny weather has the probability which is close to zero, and the rainy one has the probability close to one. So this is how we can differentiate the probabilities. We will say that the event which has the is less likely to occur, we will prioritize it as zero, like zero probability, and the event which has more chances to occur, we will call it with one probability to occur. So these are the three axioms of axiometric probability. I hope three of them are clear to you so that you can apply this or them to any conditions that are going to happen. Next, we have the conditional probability and independence. In probability, we say two events are independent if knowing one event occurred does not change the probability of the other event. If one event is going to happen and it's not going to affect the occurrence of another event, then this is the independent probability. For example, the probability that a fair coin shows head after being flipped is 1 by 21 by 21 slash 2. Basically, when we talk about this is something like a logical error, I think. This is when you will flip a fair coin, the probability of heads is 1 by 2. 1 by 2 is basically the probability of occurrence of a fair coin. But if we knew the day was Tuesday, does this change the probability of getting heads? Like whatever the day is, the probability of the occurrence of heads is always 1 by 2. We can say that the day's event is independent of the probability of the flipping of coin. So these two are independent probabilities. The possibility of getting heads, given that it is Tuesday, is still 1 by 2. So the result of a coin flip and the day being Tuesday are independent event. Knowing it was a Tuesday didn't change the probability of getting heads. So this is something which is directly related to the concept of independent probability. This in this way we can say we are not going to discuss them with each other because they don't have the relevance. We can talk about them, whatever the day it is, the probability of the heads or tails on the flipping of coin is same. Probability determines the likelihood of an event occurring P of A. It's the possibility or the probability of A with the F by N. N is the total number of chances and F could be the number for which you are going to check the probability. Odds and probability are related, but odds depend on the probability. You first need probability before determining the odds of an event occurring. Odds are something that are basically not going to occur. And once you want them, what you can do is you can determine them by the probability of them. The probability types are we have discussed them, the classical, empirical, subjective, and axiomatic, and we can determine the probability or the odds of anything by these kind of or types of probability. So this is our first concept of the probability theory. And now we are going to discuss the probability formulas and how we can use them. If you have any question or anything is unclear, you can ask. Otherwise, I'm going to continue. Okay, let's continue with the probability formula. The formula for probability states that the possibility of an event happening P of E. E is basically the event for which we are going to determine the probability. It's basically equals the ratio of the number of favorable outcomes to the number of total outcomes. How many outcomes are basically favorable? It depends upon the probability that we are going to find, and the total number of outcomes are basically the ones for which we have the chances of something to occur. Mathematically, it looks like this. When we write it in mathematical form, this is the way to write the formula. And when we are talking about anything that is related to the favorable outcomes and the total number of outcomes, we can simply divide them and get the probability. What is the use of probability in computer science? Probability is everywhere in computer science. In networks and systems, it's a key tool that allows us to predict the performance, to understand how delays changes with the system parameters and more. In algorithms, randomization is used to design faster and simpler algorithms than their deterministic counterparts. This is the whole scenario in which we are using the concept of probability. In our computer science concepts, we cannot say we can work without the concept of probability, because this is one of the major concepts that we need to use, and definitely we can continue our work with them. Random variables. In probability, a real valued function defined over the sample space of a random experiment is called a random variable, in which basically the values of the random variable corresponds to the outcomes of a random experiment. The number of possible outcomes are the basically the part of the random experiment. Whatever the experiment you are going to perform, it could be anyone according to the type of probability that we have performed, and we can use them to make our random variables probability. Random variables correspond to the outcomes of the random experiment. Random variables could be either discrete or continuous. I hope you have the concept of discrete and continuous. Discrete numbers are basically the numbers which are directly 1, 2, 3, 4, 5. But when we talk about the continuous numbers, it is basically having the all the numbers between 1 and 2, like 1.1, 1.2, 1.3. And if we generally talk about it, this is the first continuity, but there are other 1.111, or all the possible numbers between 1 and 2 are mentioned in it. So this is how we can get the probability of random variables, and they are saying that when we are doing the random experiment, the random variable could be a discrete number value or a continuous value. The probability of a random variable x, which takes the value x, is defined as a probability function of x is denoted by f of x. F is basically called for function, and f of x is equal to greater x is equal to smaller x. Basically, these are denoted by the values. The uh, Here the capital X is the random variable for which we are going to perform the experiment, which takes the value small x as the probability function, like the number of times this is going to happen. A probability distribution always satisfies two conditions: f of x is greater equals to 0, and for all f of x is equal to 1. Like the numbers could be between 0 and 1 only. When we are going to perform the probability distribution, it has only two possible options. F of x is greater equals to 0. Like it cannot be less than 0. It always needs to be from 0 to 1. And for all possible values of x, it could be equals to 1. We cannot exceed the limit of 0 and 1. Then we have, after random variable, we have the standard deviation. This is the concept of probability distribution, and it's the degree of dispersion or the scatter of probability distribution, which is relative to its mean. Mean is basically the central value or the mid of the whole number that is given. It is the measure of the variation of the probability distribution from the mean. For example, if you want to get the variation from the mean point of anything, then you can use the standard deviation. This basically helps you to find out the probability distribution, and it's the square root of its variance. Whatever the variance you get to consider by getting its mean, when you get the mean, you can conclude its variance, and the probability says that like its probability distribution says that it will be the standard deviation will be the square root of the variance. Whatever the variance it, you will take the square root of it, and it will be the standard deviation. The steps that you need to take are: find the mean, which is the arithmetic mean of the observations. Then find the squared differences from the mean. The data value minus means the whole square is equal to find the squared difference of the mean. This is basically the way with which you can conclude the standard deviation. Then you will find the average of the differences. Once you get the square differences, you will get the average of it with the help of variance is equal to the sum of square differences. All the square differences that you have gathered in the second step, you will add them, and then you will divide it with the number of observations. Let's suppose you have four number of observations and the numbers are 2, 4, 6, 8. You will add them all and divide by 4. Whatever the result will be, it will be the squared difference of the, like the average of the square difference. Then you will take the square root of that variance. And how you can do that, standard deviation is equal to square root of the variance. Whatever the result is, you will take the square root of it and it will be the standard deviation. This concept is little bit critical. I am going to explain it again so that you can better understand. First, you will find out the mean. Mean is basically the arithmetic mean of the observation. You add all the numbers, divide it with 2, and then you get the mean of it. And once you get it, you will find the square differences from the mean. It the mean is basically the data value. Whatever the value you get, you will minus it with mean and take the square root, whole square root of it. Sorry, whole square of it. Whatever the result by the subtraction you get, you will take the square of it, and after that you will find the average of square differences. Once you get the square differences, you will sum all the square differences and divide it with the number of observations. Once you get the result, you will take the square root of it and it will be your standard deviation. I hope the concept is clear. If you have any question, you can ask me. Okay, and Afan, the concept is clear to you as well? Okay, good. So this is all about today's lecture. If you have any question regarding the probability concept and its formulas and its uses, you can ask me because this is the important concept. You are going to perform your assignment activities, coming activities on the basis of this concept. So if you have any questions, you can ask me. So this is all from my side. I will see you guys in the next class. Till then, take care of yourselves.